Okay, so for this will be the last lesson that we're going to cover for chapter 11. This is going to be a continuation of areas of regular polygons, and we're also going to do composite figures. So with areas of regular polygons, sometimes we have multiple shapes. So maybe it's inscribed in a circle and so on. And we're going to look at finding the shaded region, which we did before. The shaded region, we're going to find the outside shape minus the shape that is unshaded. So let's take a look. What we have is a triangle. And if this is 4, okay, so first thing I'm going to do, I'm just going to connect this. So recall that this angle is a central angle. And the central angle is found by taking 360 divided by the number of sides. So in this case, we get 120. Now, I'm going to kind of draw this sideways. So I want the apothem. I want A. And I want to cut that central angle in half. So that makes this 60 degrees. Therefore, in this triangle here, we have a 30, 60, 90 triangle. Notice the hypotenuse is labeled as 4, which makes the shorter leg, A, half of that, which would be 2. Then the longer leg here, that will be 2 root 3, which makes one side double that, which will be, so one side will be 4 root 3, double. Okay, now we have to find the perimeter. So that's going to be 3 times 4 root 3, which is 12 root 3. Okay, so I think we have all the information that we need. So the area of the outside shape, that's the area of the circle. We want to take the area of the circle. So the area that's shaded, we want to take the area of the circle minus the area of the triangle. So the area of the circle, if you recognize the 4 meters is actually the radius. So we're going to have pi times 4 squared minus the area of the triangle. So I'm going to use the perimeter times the apothem divided by 2. So the perimeter was 12 root 3 times the apothem, which we found was 2. And I'm going to divide by 2. So this is going to give us 16 pi minus 12 root 3. So that's the exact form. So it says write exact answer. And then, so let me write that in, 16 pi minus 12 root 3. And then let's approximate that. So 16 pi, and just type it all into your calculator at once. And we get 29.48. So we'll round to the 10th, which will make that a 5, and it's square meters. Okay, for B, we have a square with a circle inside of it, and I see that half of the diagonal is 8. So if I were to extend this, I can form a 45, 45, 90 triangle. Now, if that is 8, that makes the entire diagonal 16. So if I have the hypotenuse of a 45, 45, 90, right, the hypotenuse is 16, I'm going to divide by square root of 2. So if I take 16 and I divide by square root of 2, I get 8 times the square root of 2. And that would make this side 8 square root 2. So for my area, I'm going to take the area of the square and I'm going to subtract the area of the circle. So the area of the square is just going to be base times height. So 8 root 2 times 8 root 2 minus the area of the circle. So that's going to be that's going to be pi r squared. Now, if all the way across is 8 root 2, that would make the radius 4 root 2, right? Just half of that. So that's going to be pi times 4 root 2 squared. So let's see, 8 root 2 times 8 root 2 is 128. And 4 root 2 squared is 32 pi. So that's my exact answer. And then we'll approximate. And I get 27.46. So I'll round that to 27.5. And I don't see any units, so we'll just leave it, actually. Okay, for C, we have a triangle inscribed in a circle. And I see one side is labeled as 5. Now, I notice that I have a 30 degrees. That's referring to that angle. And this is a diameter, which actually makes this 180 degrees, right? A semicircle. This is an inscribed angle, and if you remember from the last chapter, the inscribed angle has to be half of its arc. So that makes that 90 degrees. So we have a 30, 60, 90 triangle. 5 happens to be the shorter leg. So that would make the longer leg 5 root 3. And that would make the diameter 10. So when I find the area, I want to find the area of the circle minus the area of the triangle. So if the diameter is 10, then the radius is 5. And the area of the triangle, well, I have to use the two sides. Remember, you need to have a right angle for the base and the height. Base and the height have to be perpendicular. So I'm going to use the 5 root 3 and the 5 for the base and the height and divide that by 2. So we get 25 pi minus 25 root 3 over 2. So that's our exact answer. Not very pretty. And then we'll plug it all into the calculator. So 25 pi minus 25 times the square root of 3. Divide that by 2. And I get 56.88, so 56.9. Okay, for D, I have the area of the circle, and then I'm going to have to subtract the area of the hexagon. So what I'm going to do first, I'm going to picture, okay, here's my triangle I want to work with. The central angle is 360 divided by 6. It's a hexagon, so that's 60. And then I want to cut that in half. So this will be a 30, 60, 90 triangle. Now, if all the way across is 20, then each of these radii would have to be 10. Right? This would have to be 10. This would have to be 10. So this is 10. So that makes the shorter leg here 5, and the apothem will be 5 root 3. So if this side is 5, that makes the entire side 10. Therefore, my perimeter of my hexagon has to be 10 times 6, which is 60. So the area shaded is going to be the area of my circle minus the unshaded, which is the area of the hexagon. So the area of the circle is going to be pi times 10 squared minus the area of the hexagon, so the perimeter is 60. The apothem was 5 root 3, and we're going to divide by 2. So we get 100 pi minus 150 times the square root of 3. So that's our exact answer. And now let's substitute those values into our calculator. I get 54.35, so that's going to be 54.4 for rounding to the 10th. Okay, area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. That just means if you have multiple shapes connected, we're just going to add them all together. Okay, so let's see. We have, looks like a rectangle, part of a circle, and in fact, these are all right angles here. So this would be 3. This will be 3.5, which makes this 3.5. So let's see what we have. This rectangle is going to be 3.5 times 3 plus, okay, so if this is a 90-degree angle, this is 1/4 of a circle. So 1/4 times pi r squared, so r is 3.5. And then the next rectangle is going to be 5.5 times 3.5. So 3.5 times 3 is 10.5. And you know what? Let's not worry about exact answers for this. Let's just approximate because these numbers get a little funny. Okay, so I have 10.5 plus 3.0625 pi plus 19.25, and I get 39.37, so 39.4, and that will be square millimeters. Okay, last one here. So let's see, what do we have? We have this rectangle is 32 by 16. I see this triangle, right, would also be 32, and then I see 15, so that's going to be 32 times 15 divided by 2. And then lastly, I see the 2 semicircles here and here, so I could just combine them to make one circle, which will be pi r squared. And if this is 16, then the radius would have to be 8, so pi times 8 squared. So let's plug that in. So 32 times 16 is 512. Next part is 240. And then this will just be 64 pi. So let's just plug that in. So 512 plus 240 plus 64 pi. And I get 953.06, so that's going to be 0.1. And we get square feet.